Hello, this is Mr. Huber. In this lesson, we're going to work on solving systems of linear equations. A system of linear equations is two or more equations with the same two or more variables. We're going to work on systems of two equations and with only two variables. But keep in mind, you could have a system of 3, 4, 5 equations. You could have more than two variables. We're going to see where we're solving systems of two equations in two variables. Okay. The solution for a system of equations is an ordered pair that's a solution of both equations. Important to emphasize both equations. Okay? We see two equations here. These are a system of equations. X plus 2y equals 7, 3x minus 2y equals 5, two different equations with the same two variables, x and y. Okay? We could plug 1 comma 3 into this first equation and it would be a solution. We could plug a 1 in for x, a 3 in for y, and it will work. If we plug the 1 in for x and 3 in for y in the second equation, it will not work. 5 comma 5 is something that would be a solution for the second equation, but not the first one. So these points are not solutions for the system of equations. Okay? Neither one of them is a solution for the system. To be a solution for the system, it has to satisfy both equations. So let's look at how we could figure out what the solution for the entire system would be. One method would be by graphing. And we're going to try to use the graphing calculator to be as exact as possible. You can graph equations by hand, but when you graph by hand, you have to be really, really precise and exact. So if you don't have your graphing calculator to try those on, it'd be good to have that so you can practice how to do it on there. All right, we're going to use graphing a system to find out where the two lines intersect. That point where they intersect will be the solution for the system. Okay, so let's see what that looks like. Here we have a linear system. The x plus 2y equals 7 and 3x minus 2y equals 5, the ones we were just looking at previously. Right? To be able to graph these, we need to get them into slope-intercept form, y equals mx plus b, right? Y equals mx plus b form. So we take the first equation, I just brought it down here, we subtract the x on both sides, divide by 2, and we get a y equals mx plus b. Second equation, bring it down here, again solve for y by subtracting the 3x on both sides, dividing by -2, and now we have these two equations that we can graph and see where they intersect. Okay? To solve this system on the graphing calculator, and again, if you graph them by hand, that's fine, but you're going to have to be really exact in how you set up and draw your graph. Okay? First, we want to get them both solved for y, so we can enter that y equals mx plus b equation into the y equals screen on our calculator. Just below the screen on the left side, there's a button that says y equals. You press that, and then you're going to enter your equations, one for the y1 and another one for the y2, okay, so that you have both equations entered in there. So you're going to enter your two equations into the calculator, then you're going to press the second button, which is right below the y equals, and calculate is to the right of the y equals button. There's a button that's called trace, and right above it says calculate. So you're second in that button that says trace to get to calculate, and when you do that, you're going to want to go to option number 5 for intersect. You want to find out where the graphs intersect. And then you can press graph and then enter, enter, and enter, because it's going to ask you for the first curve, second curve, and a guess. Okay, you can make sure the two curves are correct. That means the two lines, equations you're trying to graph are correct. And then the third time, if you want to try and guess what the solution is, you can, but you don't have to. You can just press enter, and it will tell you then what the intersection is. It gives you an x and a y at the bottom of your screen. That x comma y is the solution. That's the point where the two lines intersect, and it should show you it intersecting at that point right on your graph. Okay. Also keep in mind what we have down here. When you enter a fraction in your calculator, okay, like we have in this equation we're working on, if you want to enter 3 over 2x, you need to put the 3 over 2 in parentheses, 3 divided by 2, like this. Some of the calculators you can enter more of what looks like a typical fraction, but often if you put it in as parentheses with division, that's going to work more universally. Okay. We've got another problem here that you can practice now. So you should try solving these for y, entering them into your calculator, and see if you can find the point where they intersect. Okay. You'll see the solution here on the screen as I scroll through it. You can make sure that you've done it correctly. So first, to solve the two equations for y, we should get these two equations right down here. Okay, those are our two equations solved for y. We have them in y equals mx plus b form. Then if you graph it, you should get the point 1, 2 as your intersection. 1, 2 should be the intersection you get when you graph those. And then you can check that. In case you graph, especially if you're graphing by hand, but anytime you're graphing, you want to make sure you didn't make a mistake in the calculation using the graphs. You can plug the point 1, 2 into the equation, 1 for x and 2 for y. You want to plug into both equations. Here's one of our original equations, here's the other one. Plug 1 in for x, 2 in for y. In the first equation, we get 3 equals 3, which is correct. The second equation, we get 4 equals 4, which is also correct. So that means this point 1, 2 is the solution for the system. This is the one point that's on both graphs, the one point that will be a solution for both of the equations. Okay. Also, if you want to look through your table of values, it shows you here where if you press the second button and then graph, you have to have both equations entered into y equals again, but you'll get a table of values. You'll get tables with x values down the left side, and then you'll have a y1 and y2, and you have all your y values for both equations you've entered. Okay, so when you do that, you can look for where the y values are equal. And where the y values are equal, that x comma y will be the solution for the system. So it's another way that you can use your graphing calculator to help you get the solution for the system using the table. All right, before we look at another example, I'm going to ask you what Mr. Huber's favorite animal is at the zoo. A few fine selections there. See if you can guess which one you think it might be. The wolverine would be a popular guess because of my affinity for the University of Michigan. The red panda is quite underrated at the zoo. Make sure you check it out next time you're there at the Detroit Zoo, or any others if they have them there. Pigs, because of bacon, might be a nice option, but it is in fact the prairie dog. They are always active and out and going. I really like the prairie dogs at the zoo. So there you go, maybe a little surprise option there, but one you should check out if you don't regularly. All right, let's look at an example where we can apply these systems of equations. So we have an example here about a business that rents inline skates and bicycles. We've got some information about how much it costs to rent each of those, and we're also told up here that they have made in a day 25 rentals and collected $450. We want to figure out from that situation how many pairs of skates they've rented and how many bicycles they've rented. So first, let's define our variables. So I'm going to set x as the number of inline skates and y as the number of bicycle rentals. Okay? You can pick anything you want as long as you are defining and saying what your variables are equal to. So at the end, you'll remember, if you solve for x and y, what they actually represented. Okay? So let's write up a system of equations. One system is going to be based on the number of rentals, nothing to do with the dollar amounts. We know that they rented 25 total rentals. Okay? X plus y. The inline skates plus the bicycle rentals equals 25. And we know how much money they've collected. They collect $15 for every inline skate rental, tells us that up here, and the bicycles are 30. So 30 for every bicycle rental, and if we add up the amount of money for the rentals, we should get $450 because it told us that right up here, $450 for all their rentals that day. So we have a system of equations, which we could solve by graphing. First, we're going to have to solve both equations for y, and then we can enter them into the calculator or graph by hand, but again, by calculator is going to be more exact, and if you get used to doing it that way, it's not terribly difficult. And so we solve the equations for y, find where they intersect as the point 20, 5. We could check that by plugging them into the two original equations. We should go up here to the original equations and plug them in. X is 20, y is 5, and make sure it's a solution for both of these two equations. 20 plus 5 will give us 25 total rentals, and 15 times 20 plus 30 times 5 added together will give us the $450 for that day. What does that mean, though? Well, now we got to make sure we remember what these variables represent. We define them. X was the number of inline skate rentals, and y was the number of bicycle rentals. So they rented 20 inline skates and 5 bicycles for that day. Right, so make sure we know what those variables represent at the end. We can write systems of equations for real-world situations and solve them and figure out what those solutions mean to that actual situation that we're applying it to.